discussion. So I definitely put ChatGPT for product managers because somehow the term large language models actually give few people some anxiety. So I was like, okay, people know ChatGPT, let me put ChatGPT for product managers. Later on, I realized I definitely lost some of the more intelligent audience there, or I would say not more intelligent, but people who are more interested in large language models. They're like, okay, I know everything about ChatGPT. I know how to write prompts and all. Tell me about large language models. So possibly a miss there, but I think we are going to cover mostly large language models because I feel you folks would be comfortable with writing prompts. If not, see, it's not very different from Google search. If you ask me, right? There are people I know who learned how to do advanced Google search. There are people who will know how to do prompt engineering and all. But most of us don't need to do advanced Google search. We can still do very, very well in Google searches, right? And same will happen with ChatGPT. You will learn how to sort of write good prompts because you'll experiment with it, go through trial and error and sort of get there. If you're still not confident, I'll just take that out of the way by saying that go to OpenAI. They have a single blog on how to write prompts. And that is the only thing that you need to learn. You don't need to go through LinkedIn posts and all those like different things on how to write PRDs using ChatGPT and all. You just go through what OpenAI says about writing prompts and you should be good, right? So I'm just taking that thing out of the way to start with so that we can focus on actual sort of good stuff, right? So before I start, like it's important to know where I am coming from, because with that context, one, it gives you more confidence to listen. The second is you can actually ask me questions and I can answer them based on the context I have. And because you know that context, you can actually be more specific in those questions. Like if you see, I have some experience in, like I'm a graduate of IIT Kharagpur, I'm from non-CS background. So people from non-CS background would relate to me because here is a person who is speaking about ChatGPT and LLMs coming from a non-computer science background, right? So I did my majors in chemical engineering, minor in mathematics and computing. And then I think my first PM experience was with Upgrad. And now Upgrad now is a $2 billion company, but when I joined, we hadn't like had a single dollars in revenue. So it was very pre-revenue. I saw the company scale to like $20-30 million in yearly revenue. And that was like the inception years of Upgrad. I was very lucky to sort of be there at the right time, in the right place and all that. And then I think the next big jump in experience came from Flipkart, where I led games and gamification. And then I also led conversational AI. So leading the AI product, conversational AI is basically, think of Alexa for shopping, right? So we were trying to build like voice search and shopping assistant for Flipkart. And that experience gave me enough confidence to say that, okay, a person who is coming from a non-technical background and all can become a good PM, but can also lead very, very deep tech products, right? Because voice search assistant is actually a pretty deep tech sort of product, right? And I see a few folks just taking one thing to mention. This meeting is getting recorded, so I will cut, of course, some parts of it. Some maybe candid conversations and always should not go public, but nonetheless, like I will keep most of it and upload it on YouTube later. So in case like some friends of yours are not able to attend and all, tell them. I'm going to deny anything to record locally. I'm recording it centrally and I will then distribute it through YouTube. Okay, so with that, let me go to like Flipkart. So Flipkart conversational AI and all, it gave me confidence. And then most recently, I was at Unacademy as senior director of product, leading end-to-end learner experience, like free learners, paid learners, iconic learners and all, right? So that's my professional journey. I think one recurring theme that you'll see in my career so far is education is something I've been very passionate about. Like, I think when we got locked down in COVID, I started writing this newsletter, Growth Catalyst. It has now like 10K subscribers, but I try to sort of simplify growth for a lot of budding PMs, new PMs, right? And there's a series of some 50 odd posts on growth that is on Growth Catalyst, simply around growth, like 9 different topics of growth, right? Nowadays, I write like back and forth around various topics that interest me, but that is a good series to look at if you're interested in growth. The second is like, of course, I wrote Tech Simplified because I got rejected at Google, and the technical round was basically the reason for it. And this is back in 2018. So next 4 years, I said that, okay, let me solve this problem for any non-tech PM who is coming into like this tech world, because that would mean, I think that would actually create a lot of impact, because these PMs can then become very effective. Not because, see, tech is required, by the way, like no matter what people tell you, you need to learn the language to speak to developers, right? So you need to learn tech. But at the same time, what kills PMs who don't understand tech is imposter syndrome. Like even if they're very good, because they fumble in technical discussions, they question themselves sometimes, right? And I feel that that should not be the reason. And this book tries to solve that. And lastly, like I'm working on PM Curve, which the goal is to help PMs create impact in their career. There is enough sort of PM literature and courses around cracking the PM interview. So I didn't want to go and crack that. Even if it's a big appealing market, my sense was like, if I can create existing PMs to sort of help create impact in their career, that would be pretty good, right? So that's basically my journey. And now this gives you enough context to ask specific questions around e-commerce. I've also worked in OTT, games, gamification, education tech, content community, running live courses, and so on and so forth, right? So feel free to drop those in chat. I would not take like a question, like don't open your mic and ask question, put it in chat so that I can take it at the right time, right? So before we go, let me just, I try to gauge the kind of audience I've gotten. So sorry, this is an old habit as a PM. So let me know what your current domain is. And as expected, most of it is from product. We have 85% product, 8% tech, 4% marketing, 1% data, 5% other. I'm going to end the poll. We have like enough sample size. So this is the result, by the way, like in full transparency. Next, just curious to know the years of experience, because that also helps me sort of tone up or tone down like certain conversations. And great engagement. Like I can see people, I've never seen this sort of engagement on polls in live sessions. Thank you, folks. I think we are just 2 more seconds and we'll stop. Okay. Interesting. So 30% is less than 2 years, which is like you folks are right to sort of start learning about these things 3 to 6 years. This is a good blend. I think we can go back to this thing. So before I start again, my current role obliges me to talk a little bit about PM Curve, but again, I don't prefer having a very promotional conversation. So I'm going to talk something which is going to help you think around PM domain in general. Like basically the thesis of PM Curve. As a PM, like I always want to sort of pick a problem and solve it. So here is a thesis for PM that I have built so far in my career. So what you'll realize is, just a moment, I'll adjust this thing. Okay. So what you realize are 2 things. So the first thing is PM has a very wicked learning environment, right? So wicked learning environment and kind learning environment. This is something which I think David Epstein wrote in Range. This is a pretty good book for PMs because it's about how generalists actually help the world crack the problems. And PM is a generalist role, so you should definitely read it. But wicked learning environments he talks about is basically the environments where feedback is very delayed, infrequent, and partial. Think of investing. When you invest in a stock today, the feedback is not very obvious. Like you have to wait years to get the right feedback in some stocks, right? So unless you are a trader, like the investing is actually a very, very wicked learning environment. You can't even match the patterns. You can't even say that in the last 10 years, this stock has gone up, so let me keep invested in this stock and all that, right? So it's a very wicked sort of learning environment. Another wicked learning environment is writing. If you're writing as a creator, if you're writing fiction and all, you don't know which book will be actually mega hit, right? So it's a very, like, there is hard to follow patterns in writing. And then there is chess, which is a very kind learning environment, and which is why chess has been cracked by AI at the first and foremost. Like in 1997, IBM Watson sort of defeated Gary Kasparov. And that was basically the people saying that AI has arrived now. And there was AI fever and all that. But then again, like we had 20 years of winter and all that in AI. So kind learning environments, there are patterns which recur, the feedback is very quick and all that. There are like X number of moves that are possible at any point of time, looking at the board and all, and which is why it's a very structured thing. And you can learn the patterns and you can master the patterns. Product management, I wouldn't say it's very, very wicked, but it lies somewhat to the left, which is the wicked sort of learning environment, which means that it's very hard to learn it's very hard to become a very good product manager by just learning the concepts. Like we are doing this session, you learn the concept of ChatGPT and all, but if you leave it at that, you're not going to be a very good AI product manager, right? So it's a very wicked sort of learning environment, and we'll talk about like what does it take to actually be good at wicked learning environment, right? The second thesis is it has ill-structured problems. So again, I think it's slightly similar to wicked and kind, but think of well-structured problems as problems that have boundaries, have a correct answer and all that, something like a puzzle. There are boundaries. There is a way in which you have to sort of, you're constrained by rules and all, and there is a correct answer at the end of it, right? But on the other hand, the ill-structured domains have no correct answer. Something like design. You can tell me to design a good experience, and good can mean like 3 different things. And which is why like companies like Apple are able to innovate, because they are able to find very non-obvious solutions, because there are multiple solutions. Other companies are also solving it. But yeah, Apple is able to come up with a much, much, much better solution to an ill-structured problem, like VR right now, right? Like VR, they went with that headset and all. And it's very unique and very, very, I don't know, like I'm just in awe with that product that they have launched. Product management, again, has very, very ill-structured problems. The feature will work, not work. People will adopt, not adopt. I'm not talking about you. I'm talking about Mark Zuckerberg. I'm talking about Elon Musk. Elon Musk is struggling to see what sticks at Twitter. Mark Zuckerberg is put like IGTV and then put Reels, and Reels succeeded. IGTV didn't. And then now Threads is the third bit against Twitter. So you see that these are very ill-structured problems. There's no definition, there's no boundary and all that, and there's no correct answer. In what format will Threads work? We don't know. In what format will VR get adopted to mass? We don't know. So PM is like that. PM has ill-structured problems. PM is a wicked learning environment, which makes PM very, very tough to master. And this is the thesis. This thesis is going to help you in general in PM, but this is the thesis behind PM curve. And whatever courses I'm designing, at least, I have to be very, very careful that there are concepts which is vital for well-structured field, ill-structured field, wicked, kind, everything. But then there are analogies and practice built into it, right? Because without analogies and practice, you can't master a wicked learning environment. And that has to be the core of the whole learning, because you can learn what is called, there's a difference between knowing the name of the things and the thing, right? So you can learn what is job to be done, but unless you actually sort of practice it, unless you see enough analogies on what is a job to be done, what isn't, you're not going to sort of learn that, right? And which is where, like, if you're looking at like how it sort of goes different, is there is like a lot of concepts around product-led growth, which is a product first growth actually, because a lot of literature around growth is for marketing and business folks. The second is case studies, which actually is a part of a lot of other courses. But the third and fourth, which is like there is a mega growth problem and there are a lot of objective questions to practice, is where this sort of gets differentiated, right? That is where practice sort of kicks in, which usually I haven't seen like any of the PM platforms doing it, right? And this is another example where product thinking actually helps, which is like you go to the problem first, you build the thesis first about the sector, and then you go after the solutions, and then you are able to arrive at some original solutions like mega growth problems and objective questions in PM. which when I tell a lot of people are like, okay, but you can't get objective problems in PM. You have to give people that, how do you increase Calendly revenue by 3x in 1 year? And they have to create a PPT of 20 different slides, and then they have to post it on LinkedIn. And then people have to respond saying that, okay, this is great. That's the only way to. My sense is no, it doesn't have to be like, unless it is very objective, your feedback is not going to be very pointed. Your feedback will always fail. And that's not the way you learn anything in life, much less like product management, right? So just one example of like some of the objective questions, because sometimes it may feel like, okay, you might be asking some definitions in objective, but this is more applicable. Like if you have power core casual buckets with size, ARPU, churn rate, and everything, which is the transition where you should focus most to sort of solve the growth problem or revenue problem, right? So this sort of thing, which is very, very real, which is very, very real in your real life, is something that we make as part of sessions. And the next is like, I think there are a few folks from last cohort. This is they know there was a Zomato problem. This time it's different, which is like you are offered to join as interim CPO of a beauty marketplace, organic beauty marketplace called Natura. It has raised $2 million and it has been struggling to grow in last 6 months. It has a runway of another 6 months. You have to define the growth roadmap and get it back on track. Now, the difference here is, rather than you solving it on a PPT, I'm giving you a real Postgres database. Like you have this database, you have users, you have transactions, you have you have a sort of add to cart impressions, every data that you find in an e-commerce company, you have access to that. You have delivery cost, you have margins and everything. And now you go and solve this problem. Don't come back to me saying that, okay, these are 5 different ideas and this feature is pretty good, right? The second is, of course, like templates, concepts from study material. And third is user research, right? Usually I've created a research document and all for the case, but to give you a sense of how research documents should be. But usually I tell PMs that you should never outsource research, which is the, like I say, that, okay, you go and do research on your own, but use the DB, use the templates, just like a real problem in real life, right? So yeah, that's basically the first segment, which is saying that, okay, how do you take product management as a domain and try to solve it systematically using product thinking that we have learned so far in our lives, right? So if it is applicable to you, like go to pmcurve.com, try to put an application there. If it doesn't, tell a friend for whom it does, right? And they will be thankful to you. So I'll end that segment with this. And now we move into large language models. Now, the goal of the session is I'm going to teach you a few things, but you'll have much to learn after the session as well, right? So the goal is to just initiate you and give you enough confidence so that you can start reading different in-depth articles around GPT. If you're building these products, you start reading even OpenAI documentation to assess which ones are applicable to your product and all. The goal is simply that. The goal is not to spoon feed you to sort of say that, okay, this is the truth, now go and apply it. Because honestly, there is no truth. And as we will see in this topic especially, people are fighting all over the world. Experts are fighting all over the world on what is the truth about LLMs. And that includes chief AI scientist of Meta, that includes Elon Musk, that includes Sam Altman, that includes Satya Nadella and everyone. Like there are people with different point of views on how LLMs are going to evolve. So don't seek the truth in this session. There is no truth serum in this session, but I'm going to get you initiated, right? After this, you'll have the confidence to go and read different technical documents. You'll have the confidence to go and sit in meetings where people are discussing ChatGPT. You are going to have the confidence to go and read even research papers, right? So that is the goal of the session. Now let's start with the first question, which often gets asked, which is why should I learn about LLM? As a PM, if I'm not building AI products, or more specifically, if I'm not building products based on GPT, why should I learn about LLMs? I think the first motivation, which is the biggest motivation of all, is people will ask you questions, at least for next couple of years, around LLMs and GPT, because PMs are supposed to be excited about new technologies. and they should be able to build a thesis and a point of view over it. So that's the first reason. The second reason is your competitors are thinking about building products. I was just talking to like one of the foremost fintech companies in India, and their like head of product is like, I want to create a small team and just let them tinker and see what they can build with it, right? So everybody is thinking about how they can use these technologies, and the ones who are able to crack this out first will have advantage. Others will follow, others will copy, but they can build an advantage of 6 months, and that's good enough to sort of build a bigger competitive advantage. So whenever there is a big technological shifts, like be it smartphones, be it computers in the first era, internet, smartphones, and now I think it's happening in AI. My sincere hope is it's happening in AI. Wherever there is a big technological shift, the ones which are early adopters actually reap a lot of benefits, right? And it's very hard to know who will be early adopters and whether you will be an early adopter or not without actually understanding it. So definitely understand it. And the third is big tech is using it in their products, and that will affect you both personally and professionally. If you're interviewing for big tech, it will affect you professionally. If you're using any of the Microsoft or Google or all these tools or Amazon sort of tools, it is going to affect you personally, right? So those are the reasons which apply to every one of you, and that is why you should learn about LLMs. The second thing is basically, this is, by the way, like a PRD. Don't you feel it's like a PRD? Why should you do it? What should be the objective? And then I'm talking about what is out of the scope, right? So out of the scope for you should be, you should not read about speculations. Is AGI arriving on the door? In fact, like there's some baby AGI. I'm like, baby artificially general intelligence. And I'm like, what is that? So baby AGI, then there will be teen AGI and all that. All these speculations, general intelligence is arriving on door or not, is good for billionaires out there, but don't try to sort of do it for you. Like, try to see if you can actually make use of it. The second is, will AI replace us? I think product management is one of the few domains which are very hard to replace by AI, because it's a very generalist sort of domain. It's not a creative domain like writing or design, where AI is making a big like step jump, at least on average writing and average design. Product management is very different. Like, it's a very generalist role combining a lot of things. So unless it solves each of those things, it's not going to replace you anytime soon. So don't get involved in speculations. The second is, don't get involved in tools that will increase your productivity 10x. And here is how. See, believe me when I say that, if it was actually doing that, it would have reached you by now to your companies. Your companies care a lot about your productivity. So there is a good chance that it does not do that. And I have tried it myself. It has actually wasted more of my time than actually helped me, if I'm being honest, because I usually use it for research and all. And I researched one whole day and I came up with some understanding. And next day I was reading some other thing and I said that, okay, but it does not matches my mental model. And then I had to go back. I had to read everything from Google, like go to credible sources and read. And I realized, okay, it had cooked a lot of things. And this is like 3 months back when it was getting hotter. So it actually killed my productivity in that case. It doesn't happen unless you are sort of trying to research some topics and the topics that you don't know about. But be careful, like, this is not increasing your productivity by 10x. The only thing this will increase is maybe likes and shares of people who write about it. The third is research papers. Stay away from research papers right now, I would say. Unless you start building the products, don't go to research papers. Even then, I would say research papers right now are more relevant for people who are actually building large language models, building it, like building something like GPT and all, like Llama and Bard. But they are not much around applications and all. In fact, like, there are few semblance. I will show you one sort of simple paper which is more around, which is now talking about applications. It just came like this week, July 6th. But before that, like, the last thing that I want you to avoid is, don't try to go after explanation of the tech, how it actually works. I have done that and it's very, very torturous. And then I realized nobody actually knows it with 100% certainty. how it actually works with 75 billion parameters, 175 billion parameters, nobody knows. If they would have known, they would have stopped a lot of problems happening in Bing chat and all that, right? But it's very hard to predict how the output will based on the input, right? So don't try to sort of understand very, very deep explanation of the tech. It's not like system design. It's very different. Like AI products are very different than usual tech products that we know, right? And this is one example, right? How we are sort of learning it now. So this came just in 6th July, which is like lost in the middle, how large language models use long context. So this paper talks about like how LLMs get the context, which is towards the end of the prompt and toward the beginning of the prompt. But something which is in the middle, they tend to forget it. And while I was reading it, I was like, oh, isn't it like us humans? So there is like, I'm a big geek on behavioral research. And there is research that you should speak either at the beginning of the meeting or at the end of the meeting. Because people remember you that way. Like people who speak at the beginning or towards the end. So in a way, LLMs is trying to sort of imitate us. I don't know. But that's a limitation. Don't put a lot of important thing in the middle of the prompt, right? Another way to avoid is don't write very, very long prompts. I know that is the general advice right now, but don't do it. The second is there is a lot of debate. Like, so Jan LeCun, I think you should definitely follow him if you're following GPT and AI. He is a chief AI scientist at Meta. And don't try to read this whole thing, but this is basically, he's making an argument that LLMs are nothing novel. In fact, they are going to hinder the progress that is happening in AI. And he is more for like symbolic systems, which are like logic systems, which is the way our brain works, compared to LLMs, which are just taking in a lot of information and spitting out in a creative format, right? I don't agree with him, by the way. I do feel LLMs are very, very useful for humans. But at the same time, there is a semblance of truth in what he says. And we will see how when we go into technical details, right? But the point I want to make is, see, you don't hear such a debate on cloud, infra, system design of Netflix, whether you should add load balancers or not. Because those are very mathematical, very, very like very clear, you can see it. But in AI, you are not able to see that. In AI, that clarity is not there, which is why I said, don't spend a lot of time on actually thinking how it works, because nobody knows how it works. It's very hard to sort of go into those parameters and decode how it works. That said, you should understand the basics, like basis, like the capabilities, the limitations and everything, so that you can build products over it, right? And that is where we are going to focus on. So we are going to focus on how it works at a technical level. Don't be too bogged down by, okay, how exactly is 1 + 1 2? Try to understand like why it matters and what matters. The second is major use cases of LLMs in consumer or enterprise products. The third is current applications of LLMs, which are noteworthy. The fourth is current limitations of LLMs. And finally, if you are evaluating it for your product or business strategy, how should you go about it, right? If you have any questions at any point of time, actually feel free to put it in chat, right? Put it in chat, I'll pick it up when I feel it's the right time. Any questions so far, or we shall move? Let's get started. So first thing first, like if you look at, this is a diagram posted by NVIDIA on their website. The first thing, and the only thing that you need to remember after this session is this diagram. So on the most foundational level, there are three parts of LLM. The first is data, the data that it is taking as input. So the data is text, image, speech, some structured data like tables and all, and even 3D signals. I don't know what 3D signal is, right? But I'm going to go Google later on and see what it is. You should do the same. But it takes a lot of data in such format. And then it takes a foundation model. Now, the term foundation model usually has been taken in some research papers and people have started using it. What they want to mean is basically this is a model that you can apply to any data and every data out there, right? So the foundation model is like GPT 3.5 is a foundation model. Llama is a foundation model and all that. So you take those foundation models, you take your data, you train that foundation model to customize it, and then you can adapt it for various things. First is Q&A, which is what you have seen in ChatGPT. Second is sentiment analysis, which is basically you can take your customer, your sales calls and you can transcribe them, or you don't even need to transcribe them because it does voice also. It can transcribe that, speech also. It can transcribe, it can tell you which of the conversations actually went right, which of the conversations didn't go right. In fact, one of the fascinating products I wanted to build long time back at Upgrad is, can I flag the calls where the customer representative actually shouted at the consumer, right? Because I want to avoid those conversations for consumers. Those are bad experiences and all that. Can you like detect satire? Can you detect humor in those conversations and all that? So that is sentiment analysis. You can extract a lot of good information from the text. Like there is a lot of text, you want to extract some information from it, you can do that. This is useful in knowledge databases that people have built in companies and all. Image captioning, you can take a lot of images and it will automatically caption those. Like this is a cat image, this is a dog image, and blah, blah, blah. Object recognition, different objects it can recognize. And finally, instruction following. It can follow instructions like you are an expert in AI and you are going to do this. Or it can follow an instruction like whenever somebody says that they have to make tea at home, get all the ingredients of the tea and then order all the ingredients. And this is a very good thing for grocery startups, for example, right? So grocery startups can actually take an instruction. What do you want to make today? And they can just break down all the recipe and say that, okay, based on what you want to make today for 4 people, we recommend you add all these things to the basket. By the way, we can do it automatically for you. And you tap that, it does all the order automatically, right? So these are very, very interesting things, which is why I said, no matter which camp you are in, whether LLMs are innovative, non-innovative, disrupting AGI or A, the applications can't be ignored. And that's why it has arrived, unlike, let's say, crypto or other things, which never got mainstream. This has become mainstream because it can actually change our lives. It can actually change our productivity and change our products. So this is what we are going to now break down. We are going to take things one by one. And we are going to start with foundation model, right? How does foundation model gets built? And what is different this time? What is something that AI was not able to do, or AI experts were not able to do for last 50 years? Because I think AI has been there since 1950 with Alan Turing and all speaking about it. What is something it was not able to do for last 70 years and now it already happens? So the main thing that happened is in 2017, Google wrote this beautiful paper. DeepMind, I think, wrote this beautiful paper on transformer architecture. And this is like the diagram from that paper. And if you look at this diagram, it's very daunting, which is why I said I don't go and read research papers. I went there, I read all this, and still I can't explain this in the most lucid form because it's very hard, right? So you don't need to understand this. What you need to understand is, with this coming in, with this new architecture coming in, and by the way, when I say architecture, it means that another way to solve a problem. We were solving a problem this way. Now we are going to solve this problem in a different way, right? So the new architecture enables you to do a few things, and we should be more focused on that. So let's focus on that, right? So the simplest way to understand architectures in AI is like, first, like I think were the feed-forward networks, right? Feed-forward means you take an input, you process through the hidden layer, which is like neural network layer. By the way, like some of the terms, if you're not comfortable with, let me explain very quickly. So hidden layer is a term from neural networks. Neural networks is basically, think of it like creating a formula of some sort so that whenever you put some input, it can calculate that and it can give you an output. So think of like predicting housing prices in Bangalore. You can build a neural network around it, and it can take some inputs like what the location is, how many BHKs, what is the age of house and all that. And then it can process the whole thing and then give you an output, right? So hidden layer is just that, something that you don't see how it is happening, but it is happening nonetheless, and giving you an output. That's all you need to understand this diagram, right? So this is a feed forward network. You feed something into it and it moves things forward, right? What's the other way of doing it? Feed backward network, but that does not make sense. You can't feed output and then get input. So then the next architecture that came in, I think 2014, convolutional neural network, or 2006 or 2014, I don't remember exactly, was a recurrent neural network. What it said was, see, feed forward is good for processing images. I can give you a cat image, it will go, you'll say, okay, cat. Dog image, go, dog. But it is not great for sequential things, like the cat sat on the mat. If I want to translate that, it's a sequential thing. The cat sat on the mat. 6 things. Now, the sequence matters, because I can say the cat mat on the sat and so on and so forth, and it won't make any sense. The sequence matters. And sequence matters more so in translation, because different languages have different semantics. Sometimes the cat can come before mat, or the mat can come before cat, depending on the language you're translating it into. So the context matters, the sequence matters, and that is where recurrent neural network actually make a lot of sense. It processes but then it provides the feedback back, so that when the cat word is processed, it has the context of the. And when sat is processed, it knows that the cat has come before sat, and so on and so forth, right? So it is doing exactly like we human process things. Right? What we do is we look at the sentence, but we don't process it one letter by one letter or one word by one word. We look at the whole sentence and we process it together. Right? What recurrent did was do closer to it by saying that, okay, whatever is already processed, we'll feed it back. And which is why it's called recurrent neural network. It's recurring. It's moving the feedback back into the system to process the next set of words. And this was still powerful. But the problem is, this is slower, because we are still processing one word at a time. Even if it is getting feedback and context from the words that were processed earlier, right? So there are a few problems with recurrent neural network. The first is sequential processing still happens, which means there is no parallel computing you can do on all words, which means it is slow. You can't process 4 billion words or 5 billion words or 10 billion words, which is like the size of internet, using recurrent neural network, because it processes one word at a time and then feeds back. The second is it has something called vanishing gradient. Now, vanishing gradient is interesting because it's basically saying that as you move farther from a word, it loses that memory. It more of a short-term memory, right? Like, I don't know how many of you have seen Gajini, or what's that English movie for Gajini? It's Nolan movie. Memento. Yeah, Memento. So Memento, right? So it loses everything beyond 15 minutes. And that's what happens with this also, vanishing gradient. The moment it reaches on mat, it has lost the cat. And the moment it reaches quietly, it lost the sat. And then it's saying on the mat quietly. Let's think what is on the mat quietly. It's actually frustrating, right? So it's not very useful for long sentences, the recurrent neural. And by the way, we are not talking about some age-old thing. I'm talking about something that arrived in 2014 on the AI scene, right? So it was the latest thing before transformers. And it's important to understand the limitations to see what transformer actually solved and became so popular. And the third is, this RNN does not know what is coming next. So when it is processing mat, it has previous words only. It does not know quietly. So again, this becomes a problem in setting the context. And because of which it is less effective in understanding the whole thing, right? Enter the transformers, right? Now the transformers are different. Transformers say all the input goes at once. The cat sat on the mat quietly, everything will go at once. And you might be saying, okay, but how does that work? Right? How does that work is, it goes after, you might have heard these thing called tokens. And I'm like, okay, there are words, but what is tokens? Tokens are nothing, but basically think of like all words in English language don't accommodate, like, let's say something like a comma, semicolon, and other things, right? So one is, of course, punctuation. It gets treated as a token. And sometimes, like, even words get dissected into tokens because the processing is easier and whatnot, right? So the text needs to be converted to tokens, which is like the cat sat on the mat, and then there is full stop, which is another token, and all that. It's way easier. So you take these tokens, and then you do word embedding. Now, word embedding is important to understand for you, because that helps you understand one of the key limitations of GPT, which is hallucinations, right? So how do embedding work, right? So very simply, the way embedding works is, think of like you have these words: cat, kitten, dog, houses, man, women, king, queen. These are words, right? And think of, there are 7 different attributes that you define. You're saying whether it is a living being or not, whether it's feline or not, whether it's human or not, gender, royalty, verb, plural or singular or plural, right? Cat is a living being. It is a feline. It is not a human, which is why you see 0.1. Gender, you don't know. So it's 0.5 approximately. Royalty, no. Verb, no. And plural, no. So between -1 to 1, it gets assigned some score. And the closer it is to 1, the more stronger is the attribute. And you see all this. And what you have now seen is the 8 words have been reduced to 7 different traits. And now they are mathematical, right? And because they're mathematical, I can see the similarity between 2 terms. Like, is man similar to women, or man more similar to king, right? Is queen similar to women, or queen similar to king, right? If you look at this thing, queen is more similar to women and king is more similar to men, right? Houses is very different than dog, kitten, cat, man, women, king, queen, because all of them are living things, right? But houses are not. So this way you are able to map where different words exist. So house will exist very, very close to home. It will exist very, very close to apartment, building, and all that, right? So this is what, like, word embeddings, what they are doing is they are converting words into mathematical format, and they are saying, okay, this word is closer to this basis this mathematical form that I have, right? So, okay, just it's slightly heavy. This is the heaviest of the section, so just hold on for a moment. So you took the sentence, you tokenized it, and you then created word embeddings, which is a mathematical representation of tokens, which is just saying that based on the attributes, I'm going to define a particular word. And how many of these sort of attributes does a language like GPT support? GPT, I think, has some 1,000 or 300 to 1,000 sort of different dimensions of the token, which is basically this living being, feline, human, gender. So using 1,000 different traits, it is defining every word out there in English, which are like what, 30, 40, 50,000 words in English in total, right? So the word embeddings convert this mathematically. The other thing that they do is they actually sort of simplify processing, because it's very hard to process 50,000 words. It's much easier to process a formula with 1,000 sort of variables or 1,000 words, right? So that's what it does. And the last thing that it does is, because it's taking the whole sentence, it creates the context of every word. Every word, for example, if you take it says, okay, what all it relates to. So it relates to it relates to monkey, it relates to banana, and it also relates to hungry, isn't it? It does not relate much to because, it does not relate much to that, it does not relate much to because it is representing a monkey. And that is how it is able to process all words at a time, because it's taking all these words, converting them into tokens, converting them into mathematical forms, and then saying that these words are related to each other strongly, either strongly or weakly. And when this whole thing comes out on the other end, it goes exactly like human brain. When the machine is reading it, it says that, okay, if I have to process this, when I'm trying to look at it, what else do I have to look at? The monkey banana. When I look at banana, what else do I need to look at? The monkey and all that. And suddenly all the words can be assembled very, very easily into a coherent format. Because it is paying attention to all the other words in the sentence, it is able to very, very quickly sort of process this whole thing. And which is why the title of the paper of Transformer was Attention is All You Need. It's very poetic. A lot of data science papers are actually poetic. But this was basically saying that if you pay attention to other words in the sentence while processing, you can do parallel processing and you can have long-term context, because it can have the context of the and monkey, which are more important than it maintaining any context of because, it, and all that, right? So that's basically the paper. If you don't get it, don't worry. I also don't get it 100%. And I believe like a lot of people don't get it 100%, including some data scientists and all. So don't worry about that. What you need to understand is now look at the problems of RNNs, right? First, sequential processing, which made it slower, got removed. Now you can do parallel processing, right? It's much faster. Second, vanishing gradient is solved. It's not a memento or Gajini anymore. It means that long sentence can be processed parallelly, and then it also, because it saves the relationship, it attends to the parts which are more important for while processing a particular word. It can actually maintain very long-term context, long-range context, right? Because it does not have to maintain context for every word out there. It just have to select the ones where the context is very, very important, right? And the last is, it actually knows what is coming next because it is taking the whole sentence as a whole, right? So better context. And this can result in better translation, better Q&A, more coherent paragraphs that the AI writes, and everything that we can think of that ChatGPT or GPT is doing, right? So it is faster, it is better, it is more intelligent, seemingly intelligent. It sounds more intelligent. It can maintain long-range context, and it can maintain better context, both for the words going before and going after, right? So that's basically the transformers for you, right? If you have to summarize the whole section, what you have to say is the reason transformers are so effective is because they can process very fast, because they can parallel process. They can maintain long-range context because it has attention built into it, which is like one word paying attention to some words which are more important to it. And then finally, it knows the context of what's coming next and what was before, as compared to all the early models which didn't know what's coming next. And which is what makes transformers so interesting and so appealing. Now that that part is done, let me take some questions and then when does the recurrent network know that it has all the information, feedback it needs? How does it avoid going into infinite feedback loop? So Pooja, there are stoppers. So even in ChatGPT, you might ask the same question. When does it know where to stop? That has a different answer, but the thing is, like, it recognizes that from here on, whatever words it is going to generate are not very relevant to what it has generated so far. So that is where it stops. For recurrent network, it's very simple. The cat sat on the mat, the will go first, cat will go first, and it will keep sending back the context of whatever it has processed. So the moment you reach the end of the sentence, it is the end of the sentence for inputs, and it is the end of the sentence for outputs, right? So there is a stopper built at the end of the sentence or at the end of the document whenever you go after these models, right? That stoppers actually helps. How does it embed the value of the word? Is it random tokenization? Yeah, so embedding is very interesting. You can actually read more about embedding, but embedding, think of embedding as this. You can either define these attributes, or you can, a more intelligent way to do it is you take all the internet text and look at which words come together, which words lie together, for example, I said, I bought a home in $35,000. And then there is another sentence on the internet, I bought a house at $35,000. And this helps the whole language understanding gets built because of this into the model. Because it knows which words come together, which words are far apart, which words don't make sense together and all that, because it has read all the text on the internet, right? And because of it is able to build the relationship between words and all that, and that's how it creates the embeddings. And the dimensions is just saying that, okay, how many variables do we need to sort of keep so that I can create a mathematical representation of the word, right? But in simplest form, what it is doing, it is reading the whole internet. It is looking at which words come after which words come together, which words can be interchangeably used. And that's how like the language works. That's the most you can do to build an understanding of a language, right? Add to that, it can access all that data at any point of time and those things. So it makes it very, very powerful. It's not random. It's actually like pretty beautiful, the embedding. Similarity calculation, Abhijit has asked, right? So similarity, Abhijit, happened in earlier models. Here again, word embeddings actually help in similarity, because the ones where the whole thing, like we saw in the earlier example, right? Similarity between women and queen is very different than women and houses, because house is very different. So similarity gets taken care by whatever this embedding you generate. You don't need to worry about that. You just need to look at difference of these two embeddings, and you will be able to see which are similar, which are not similar. Tokenization, Arjun, again, tokenization is just breaking words. So most of it is words, actually. If you look at the tokens, if you just go, the best is basically you say generative AI tokens. Example. So see this DOIT is a great company to work for. DOIT is a great company to work for. Most of it is actually getting translated word by word. But dot becomes a token. DOIT, because it's not a standard name, it becomes 3 tokens. Do IT. Right? So tokenization basically is looking at a sentence and sort of breaking it into something which machines can understand. Right? It's that simple. And that, which also means that different models will have different ways of breaking tokens. It is defined by the company, not like a universal language like TCP/IP and all that. Right? So what you need to understand is tokenization is a process it's basically processing before feeding it into machines so that it can then convert into embeddings, and then it can go on to process the whole thing. Parash is clustering. Yeah, Parash. Clustering is again another data science word. But yeah, it means that similar words occur together. And in embeddings, I'll show you how it happens actually, now that we are here. Word vectors. So look at this, right? So think of it like, if I'm using 3 attributes, it's a 3-dimensional map. If I'm using 1,000 attributes, it's a 1,000-dimensional map. And in which the words are floating, and king is closer to queen, maybe man is closer to king. King is like far away from women and all that, right? So this is how the word embedding gets created. It's basically n-dimensional field in which words are floating. And the words that are closer to each other are similar. The words which are far away from each other are not similar. Right? So that's the analogy that you should take. Okay, now that we have that out of the way, we can move to more interesting bits. Generative AI. So let's go after this sentence, right? How generative AI is working. The only thing you have to know about transformers is that they allow these language models to read human writing, to pay attention to how the words in such writing relate to each other, and to predict what words will come next based on the word that came. Now help me understand which is the right answer. What will come after came? And this is a real case study in now sort of how generative AI works. The answers that I'm getting is a real case study in how generative AI works. That's come on. 5 more seconds and we will just pick, like it's not going to be an assessment which will assess how intelligent you are. It's just a way to show things, how things work. So look at this, right? The only thing you have to know about transformers is they allow these language models to read human writing, to pay attention to how the words in the writing relate to each other, and to predict what words will come next based on the word that came before. Before is 73%, last is 21%, back is 5%, and hello is 1%. Generative AI, when it's trying to pick the next word, works exactly like the way we are thinking. Before is most occurring thing it has seen. So before makes the most sense. It has the highest probability to get picked. Last has the next best probability. So if you're saying that, okay, you be more creative as ChatGPT, it will actually go and pick last rather than before. Before is safe, last is creative. And if you say be very creative, be a maverick, it will go and pick back. It will not go and pick hello still because there is some threshold it will set. But this is exactly how generative AI is working. It's looking at a corpus of text and saying that, okay, what makes sense to come next? And the moment it has reached the end of the sentence, it then says, okay, does it make sense to add another sentence to it based on what I've written so far? If it does not, it will just end the answers, which is why you see like in ChatGPT, some of the answers are just 2 paragraphs, whereas others are like 5 paragraphs. How does it know when to sort of stop? Right? So the generative AI is doing exactly this. It is predicting which words will go next based on the word embeddings it has created and all that. And then sort of going forward, right? In another example, just to reinforce that, the boy went to grocery or park, both are correct. But if you look at the internet literature, park makes more sense. Grocery is more creative. During is more creative. Grocery store is more safe. Park today, yesterday is more creative. When I say the boy went to park yesterday, it invokes a story in our minds. But when I say the boy went to park today, it does not invoke a big story. Okay, went to park today, great. You're telling me about today. That's fine. So it feels like a normal conversation. So this is how like it is calculating probability at all steps, and it is generating one word by one word. And that's how like it keeps printing text in basically answers when you ask a question. I'll just pick if there are any questions. Now let's go into slightly more nuanced, right? So you said, okay, Deepak, this is fine, but how am I going to use this for my own product, right? And this is basically the Vertex AI, which Google provides for you to use large language models and build your own products, right? And if you look at this thing, the most you have to do is, of course, a prompt is very clear. You have to prompt a response, but these are the tweaking parameters of the model. So you choose a model. Which model is it? A model is like GPT-3 is one model, 3.5 is one model, 4 is one model. Bard will have different models and all that. So you pick a model. Maybe you pick the most advanced model, or you pick the most cost-effective model. Then you set the temperature. So higher temperature means more creative. Lower temperature means less creative, right? So if you put the temperature to 1, it can generate a lot of garbage also. Because if you're being creative, it can become like garbagey, or hallucinations will happen a lot. So temperature is a very, very important parameter. Usually people set it at 0.7, 0.8, 0.6. If you are building an enterprise product, you might want to keep it to 0.2, 0.3, and so on and so forth. The second is token limit, right? How long should the response be? Because you are incurring cost at generating every token. So, which is why they are giving you a way to choose, saying, okay, this is my token limit. I'm going to generate responses at most 5 sentences long or 50 tokens long. Then it says, okay, what is your top K? Top K, any number of most probable tokens to consider as next token. So in the last example, we said okay, there are 4 options and there are 4 different probabilities. Now you're saying if my just pick top 2, then it will just pick before and last. If you say pick top 3 and evaluate which one to sort of go based on temperature and all, it will pick before, last, and back. So top K is that. And then top P, which is what is the probability below which it should not pick. For example, in the last case, if you had said that if probability is less than 20%, don't pick, it will never pick hello, because hello, I think what 1% of you only voted for. So it will not pick hello. So all these are important. For enterprise or safer products, P will be higher, top K will be lower, temperature will be lower. For more creative products, temperature will be higher, token limit will also be higher, top K will be higher, top P will be lower. And this is what you need to build a model for your own product. Rest everything I think they've covered in here, but this is the most important aspect. Rest everything around how to upload data and all that, but those are like, I would say, slightly easier bits. But this is where like you have to tweak and you have to see. You can actually test like where are you getting good responses in 5 different prompts that your customers might see. And then you can say, okay, I have tested it on various temperatures and token limits and top K, top P, and this is the configuration which makes most sense for my product. And this is exactly what prompt engineers are supposed to do. They are sort of defining what should be the tuning, fine tuning of the model. But for your team, I would say PM should be doing it, right? So that's basically the thing. I will come to, like Akhil, I will come to your question in data and training around data. So training and tuning, right? So training for these things, like for example, ChatGPT, it took the whole internet, 4 billion text and whatnot, a lot of images, and it trained the model on that. Now, the training usually happens in AI models in 2 formats. One is supervised, the other is unsupervised. Supervised means I am taking some images, I'm tagging them, and I'm giving it to the model as a training data. Unsupervised means I'm not doing any human intervention. I'm not telling the model what is what. I'm just giving them data, more data. Right? Now you can't take the whole internet and tag it. It will take like billions of women hours. So what do? It has to be unsupervised. And the solution to that was basically saying that whenever I'm looking at a sentence, whenever you are going through the instruction to the model was, when you go through the sentence, the man went to store to buy a gallon of milk, mask few words, omit them in the input, generate an output, because you are trying to predict what word will it be, predict what are these 2 words which are masked, and then match that to the actual output. It's such a beautiful thing, right? It's like the best way to learn English. Like I remember when I used to wrote, like I used to remember like social sciences or science. I used to put my hand on my copy, look at the question, and I tried to remember what the answer was and then saw the answer. It's doing exactly that. It's taking a sentence, masking few words, and then sort of feeding it into input, fill in the blanks. The model fills the blanks, and then it provides the answer key and says that, okay, here is where it has gone wrong. So go back and fine tune your parameters. So unsupervised learning is happening, and you just need to feed more and more and more data for this model to work, right? And which is why you see like a big jump between GPT-2 and GPT-3, where like it went to 176 billion parameters. By the way, parameters are nothing but variables in the equation, right? So when you look at y equals to mx plus c, there is just one variable, which is x. Or you can say y equals to m1 x1 plus m2 x2. There are two variables, x1, x2, and so on and so forth. It is looking at 176 billion variables. And which is why I said, if you are generally trying to explain how it actually works, you can't do it like that. That's why it's called deep networks. That's why it's called hidden layers. It's hidden. You can't explain it because it's so vast and so like 176 billion variables. The second is the training data, right? 570 GB training data set, books, articles, websites from the internet. And that has become the problem with GPT also, right? Like Reddit, Stack Overflow, all them are claiming that you took our data and trained the models on it. So better give us some share of revenue or something like that, right? That is going to come a lot in recent AI conversations. And then finally, it became more generic, like more intelligent. Most language tasks it started doing without additional tuning. And finally, in fourth one, it launched an API service. So GPT-3, 3.54 all have APIs, which developers or product teams can use to, for what? For all of these things: Q&A, sentiment analysis, information extraction, image captioning, object recognition, instruction following, and all that, right? These are the major use cases. Not to mention speech to text, image to text, structured data processing like SQL query and all, like all those things are possible now, right? The last thing that OpenAI did in building GPT is this is the foundation model. There's transformer, then GPT took it, trained it, and then it created Instruct GPT in Jan 2022, where it says that now GPT can read and follow instructions, right? So it created a set of questions and answers, and it gave that as a sample data to GPT model and said that, okay, the way we are answering the questions is how you have to process the questions and answer. And that was Instruct GPT. And on that, it added a safety guardrail layer because it can generate a lot of violent or other things, because the internet is full of like violent gibberish and other things which are not safe for work. So it added safety guardrails, and finally the ChatGPT is ready. So 3 layers of any model is the foundation model, which is GPT or Llama or Bard, the RLHF, because if you give whatever you build some semblance of how should it answer, it can very quickly learn. And you don't need to do a lot. Like you can just give 100 Q&A or 100 like ideal data set. In some cases, you can just give 2 or 3 instances and it will learn, right? So RLHF, reinforcement learning through human feedback. And then third is safety guardrails. Okay, you should not do this, right? And you have a chatbot ready. You have ChatGPT ready for your company. Again, I'm going to stop on this. You can now see and think, because I said this is the only thing that matters. And we have talked about data, we have talked about model, we have talked about tasks. Now is the time for you to think and ask questions. Meanwhile, like I'll take a few questions from the chat. A few firms offer models to take a standard model and customize according to company data. How is data privacy taken care of in this case? So Akila, like in this case, your company data lies with you. I don't think they're asking you to upload the company data to them. If they are, then you should not go for it. What they are saying is, we will give you a model, foundational model, which has all the variables and the formulas and everything stored in it. You train it on your text and then you use it as per your purpose. The other model is cloud-based model, where like, see, you anyway store your data on Google Cloud. So you should have no qualms about using a Google model and putting data there, because it's almost like Google Cloud. So for startups, I think I would be more wary on going after this. But for companies like Google and Microsoft, you should not have any qualms about putting your data there in the cloud. And does that make sense? Please comment if it makes sense. If not, like put a follow-up question. When I ask this question, good question actually, since quality of output is heavily based on input, and if the input is biased, are there efforts to make sure the output is not biased? When I like the whole AI domain is suffering because of that. And like whatever biases we have in society actually eventually reflect in the data, and they eventually reflect in the models. What they are doing is the third step, which we covered, right? Which is safety guardrails. So safety is taking care of what is politically correct, what is not racial, what is not sort of biased and all that. That is what safety guardrails are for. And that is where most of the effort right now is going in models. Like be it Bing, be it Bard, that is where most of the effort is going on. I think Harsh has, Saurav has this question. Is it possible to bias from the training data and make the output less biased in neural network? Yeah, Saurav, see, anyway, it's, you have bias in the data. What it will do is it will cut that out, right? So what you are saying is we will get the output which is biased, but we will cut that out. But it can't happen that it will not have that bias as an output, raw output. Raw output will always have bias, but your final output does not have to have that bias, because you can send back that and say that, okay, don't speak about these things and all that. You put it as an instruction to that, and then it will provide an output which is less biased. ChatGPT foundational model is GPT-4 and GPT 3.5. You get both options. 4 is available only to paid users. 3.5 is available to all users. Sanmeet has last slide where you mentioned how to create ChatGPT for a specific company. So for a specific company, Sanmeet, again, what you have to do is, let me just go back. You have to go to one of these like model providers, and they have pretty good documentation, right? So the step one is uploading your data, like whatever, let's say you want to build a customer service bot. You upload your data around customer service queries, all the documents and everything that you have. So that is basically database creation. The model will take that as an input. And then you come to this prompt and response thing, and you tweak it out. Like you adjust temperature, token limit, top K, top P. You use different models, write the prompt and see what the responses are coming. And then decide on what sort of model you want to use and what sort of tunings you want to use, right? So first step is upload the data. Second step is tune the model. Third step is then finally put it in production. Does that make sense? I will elaborate it more if you still have some confusion towards the end. I've heard this term called quantization in context of training a foundational model. What does that mean? I don't know, Abhilash. I don't know what that means, but I can definitely sort of Google and find this out. Or if you Google now, you'll be able to understand the term. That's my assurance. Neil has this question: with ChatGPT making level playing field on many fronts, what could be ways to build a competitive advantage? We are coming to that. Senior manager, I'm required to understand generative AI to make it necessary. How much of the hood should I pop and look deep? I think, Arvind, as far the depth goes, this session is good enough. I think where you need to invest major of your time is like the use cases and the other product things that I'm going to talk about. And there's a framework to it. I'll just explain. NLQ, natural language query something, right? So I don't know the short form, but usually NLQ I've heard in terms of like you write a natural language query and it will query your database and fetch the right data. You don't need to write scripts or SQL queries and all that. But if that is not that, then we have to Google and understand that. So NLQ usually is used in that context, where you provide an instruction in natural language, that natural language gets converted into SQL query, the database gets queried, and then you get the results. I think Chanchal's question is answered. Sanmeet's Chanchal's question is answered. Okay, there are other questions, but I'll come to them. Let's first cover because people might have a time limit. So major use cases, I think there are two, and the first one is not that relevant. You should have a pulse check on that time to time. The second is more important, which is you building applications, right? So plugins, I think if you want to understand plugins, there is a blog post I wrote in Growth Catalyst. You can go and check that on like what these plugins are, why do they make sense, why did ChatGPT sort of GPT built on it, OpenAI built on it, and now Bard is also Bard also launched a lot of plugins, right? And where do they succeed, where do they fail, right? So go and read that definitely, but just to summarize what that means is basically, see, what's happening is so far, if I go to Expedia, let me go to Expedia. If I go to Expedia, what I have to do is basically I'm going to Chhapra. By the way, this is my hometown. And I'm trying to find a place to stay, right? Now, over time, I want to say, okay, I want to have 3 adults, 1 children, and this, I want to get things in this price range, low price. I want breakfast included. This whole thing will take me some time. What if you could just say, I'm going to Chhapra on these dates. I'm going with my wife and kid. We want a budget-friendly hotel, which has a pool and which also has a gym, because I want to go to gym. What ChatGPT will do is, if you have the plugin, if Expedia is the plugin, and if you type this into Expedia plugin, ChatGPT understands natural language very, very quickly and very, very effectively, because it is able to process the whole sequential thing very, very easily. It takes that, breaks that into different filters, sends this query to Expedia, and fetches some good results to you. So in a way, it is trying to 10x the experience of search and discovery. That's where we are with plugins. That's the simplest and possibly the most powerful explanation that I can come up with, right? And you can put this on any of these, right? Fiscal Note, what it is doing, Fiscal Note has a lot of research papers. You're just searching for something. It finds the information in those research papers and put it to you. Instacart, again, the thing that we discussed, which is like, you tell the meal, it will get the ingredients, and you can order it from here. Kayak is again same as Expedia. Shopping, you tell that you want a blue jeans, which is like your height is this, your weight is this, your waist is this, and it will create a very good search and filter experience, and it will give you some thing and all that. OpenTable, Shop, Speak, Wolfram, Zapier. All of these plugins are working like that. Wolfram is, by the way, slightly different. Wolfram is actually adding to ChatGPT, because ChatGPT can't solve mathematical problems very, very effectively. So it is using Wolfram, a whole database, to help you solve these problems. Wolfram is slightly different. You can read more about it, but more or less like this is what the large language models are doing. In here, Spotify, you search for a song. I don't know why Spotify is here, by the way. Maybe it is here because I want to say that I'm feeling sad, I had a breakup, recommend me some songs. And I can't say this to Spotify in search, but I can now do it with LLMs, right? Indeed, again, job search, search discovery, right, is where plugins are coming in. So if you have a search and discovery problem, or if you have a support problem, which is again a search and discovery problem, you can use them. That's why Stripe used it. That's why like Replit is different. That's why like Khan Academy is using it, because it is able to explain something to a student in a much, much lucid way. So that's basically plugins. I'm not going to spend a lot of time. You go and read from Growth Catalyst. The second, which is more interesting, is products which are built on top of ChatGPT. And the first place to look at is basically look at the use cases of which products can be built on top of ChatGPT. And if you go to platform.openai.com, you have this, like it solves for Q&A, it solves for grammar correction, it solves for summarizing in simple sentences. It converts natural language to OpenAI. text to command, English to other translation, Stripe, SQL Translate, which is, I think, the natural language query is, and so on and so forth. But it gives you a very good, this is just few of them, but it gives a very good sense of what are all the use cases which are possible on top of large language models. And in here specifically GPT, right? So you can understand the use cases from here. This is the best place to understand. And now let's come to, now that you know how to look at use cases, how to look at plugins, now let's come to actual products which are built using LLMs, right? So there are three distinct cases in products which are built using LLMs. The first is where core products are built on top of LLMs or GPT, which is Jasper and copy.ai. What Jasper does is basically if you want to write an article for your blog, it generates based on the context that you share. And you can keep generating more and more and more and more, keep modifying, keep generating. So Jasper is very good for like writing SEO articles and all, because you want to generate a lot of content in a short amount of time without investing a lot of costs. So Jasper is good for that. Copy AI started as a copywriting, but I think it's also moving in the direction of Jasper AI. So writing is one place where core products are built on top of GPT because, of course, it processes sequential text. It generates sequential text. So writing has to be disrupted in some form or other, right? So these are like core products. If you're, most of you are not working on a core product, is my belief. So you will work on some adjacencies, and adjacencies is where you see all these different companies launching Miro AI, Notion AI. Notion is sort of helping you write docs. Google Docs is also going after that. Microsoft is going after that. So it is assisting the capabilities of an already built product, right? And this is again very, very crucial in writing products, project management, and all those tools. And it is also crucial in support, sales, sort of functions, even marketing to some extent, right? And design, of course. And the last is, basically it is improving the core use case significantly, not adjacency. It is not just another feature to it. It is actually improving the core use case. And the best example for this is Adobe sort of Firefly, which is solving for so look at how powerful this is, right? You remember Photoshop. This is Photoshop multiplied like 1000x. Photoshop did exactly this by taking 2 hour, 3 hour, 4 hour time. Anyway, you get the idea. It's one of the like most marvelous use cases that I've seen for generative AI. So again, three things, right? And mostly you will focus on either adjacencies, which is this as a feature, or this as improving your core, like if you're building a content product or you're building a design product or you're building something else, where generative AI can actually improve the core capabilities by 10x. I think you should go for that also. So these examples will actually help you create a good mental model on whether you are going to fundamentally work on it, build some features on top of it, or fundamentally integrate it into the way your product experience works, right? So look at that. And then we come to the final question, which is like, should you use it? What is the framework for that? Which is, I believe, a lot of you are waiting for, right? See, the first thing is if you have understood what we have done so far, you would be able to map how should you use it or not, right? Because the first thing is like, you have to understand the abilities, and you have now understood the abilities of ChatGPT. The second is the cost of it. Now, cost we have not covered, we are going to cover, right? And cost is a function of the model. Which model are you using? Like GPT-4 is more expensive than GPT 3.5, and so on and so forth. Subscription tier, again, different features in different subscription tiers, and the amount of usage you have, right? So cost is a factor of that. Let's take a case and solve it and see like what is the cost going to be. And the third is, are you okay with limitations? And what are you going to do about limitations? And the most important limitation is hallucination, which we are going to talk about, right? So second and third we'll talk about. First, I think if you have any questions in abilities, put it in chat, I'll pick it up. So if you're looking at costs, let's look at a very simple question. There are 15,000 visitors which are asking 25 questions a month. Suppose this is your support function. What is your closest guess for the cost if you are using GPT-4 model? I'll just put it in. Just take a random guess. See, 15K visitors is not much. It's mostly a startup. So what is your guess the cost will be? I'm going to wait 5 more seconds. Don't Google it. You're not going to get this answer through Google. That's why I'm asking you to take a guess. 5 more seconds and we'll close this. Okay. So 43% have $1,000, 42% have $10,000, 12% have $50,000, and 3% have $100,000. I think people who have put 50 and 100, they play poker a lot because they're like, why is this person asking this question? Must be expensive. So if you do the calculation, let's do simple calculation, right? It's not that rocket science. 15K visitors asking 25 questions a month. This gives you around 375,000 questions. Now each question will have an input of the question, which is 100 words or 100 tokens long, and output size. Let's say you say 2000 tokens or 2000 words is the limit of output, right? P value, K value, not K value actually, limit, token limit. So if you look at every question will have 2100 tokens utilized. 375K questions will have 375K multiplied by 2100. Now the difference is for input, which is the question, the cost is different versus the output. The input for 8K context is 3 cents per 1000 tokens. Output ke liye 6 cents per 1000 tokens. I just put that into calculations, and this is coming as $46,000 per month. Now you understand why it's not so simple to build products on top of GPT. It's the cost, right? Because 15K is not a large scale, but $50,000 a month, it's large. And now if you look at it, ChatGPT pricing makes sense. It's charging what, $20? Let's say it has 15,000 people. This is coming as $3,000 per month. Now, it can assume a conversion. So the cost is, let's say, 46K, or for GPT, it will be even lesser. But this makes sense because not all people are paying, right? So for 15,000 that are paying, there are 150,000 which are not paying. So which means that it has to recoup that cost through those who are paying as well, right? So this sort of helps you put some sense of costing and how you should go and sort of calculate costs based on tokens and all that. Most of the times treat tokens as words, right? Don't worry much about like what is a token, what is a word. I think you should be fine taking tokens and words replaceably. So does this make sense? I think few people dropped off just by looking at the price. Yeah, the calculation is right. So I removed the 1,000 here. The pricing is right. The calculation is right. I went to, okay, I should not boast. I went to IIT. But, oh, what? Okay. Limitations. limitation. Let's talk about limitations. Are you fine with it? So the first is it does not fact check, right? Which means that your customers might see something which is not true. So how do you limit that should be your goal, right? Whichever data science team you're working with, you should be working with them to figure out how do you enable fact checking and how do you enable more coherence. To enable more coherence, you can go for lower temperature, you can go for lower K values and higher P value. So that way you can at least make sure that most of what is being presented is factual. Hallucination will also be taken care by that, right? And the last thing is it does not really understand what it is saying. See, ultimately it's predicting text, right? It's not that for me, for example, to write an essay, I have to first know what I'm going to say, and then I will start writing. ChatGPT is not doing that. ChatGPT is taking one word at a time and just generating the next word based on the context it has been given, right? So it does not really understand the way we humans do on what it is saying, and which is where like the reservations from Lee Yukin and all those like AI scientists is, which is if it does not understand what it's saying, there is a limitation, big limitation to it, right? So those are the limitations. So in professional setting, you would be evaluating that. In personal setting, the only advice I will give you is you should use it for personal productivity if you already know the answer or you have a way of verifying the answer. If you don't know the answer, then you will be like me. You will be basically researching something and thinking that I understand this. And the next day you go and you try to present it somewhere and then you're like, okay, somebody tells you that that's not true. Did you read it somewhere like which is not a credible source or what? So definitely like use it when you already know the answer and have a way of verifying, but don't use it otherwise. These are some of the examples of hallucinations of AI, right? So for example, Bing, sometimes it puts wrong dates, sometimes it puts wrong name, right? The book is I'm a mathematician. It creates some book name, the human use of human beings. and the reviewer name also it got wrong. The writer name it got wrong. But most importantly, when you ask it to present links, it creates like the links look like they are real, but when you go there, they don't exist. Why? Because it is again generating tokens one by one. So it will have some semblance of reality. But link method, like the link has to be the link, right? So that's a problem. And Google Bard is not an exception as well. It also creates a lot of facts. So yeah, don't use it unless you know what the answer is. And for your company, make sure you do enough testing before launching it. Again, I think this answer you already know. The reason it hallucinates is because it is looking at probability of next word and picking the next word. Sometimes the probability might be high, but it might not make sense. It might not be factual, right? So yeah, that's like how you should use in your product. And this is the last one, which is like, then in this era, like have the companies already won? Is OpenAI unbeatable? Will OpenAI kill other companies and all that? None of that is actually true. In fact, Google sort of published it in one of their internal documents, which got leaked, where they said that we have no moat, and neither does OpenAI. The moats are the same as they existed in earlier era, which is network effects, scale, cost leadership, and all that. And very clearly, you can see if you look at the Porter's sort of generic strategies, and if you look at like cost differentiation or focus, like you can see companies actually getting built in focus segment, because the cost-wise leadership will be there with Google or bigger companies. General differentiation for the market, which is like, if you look at all the market, the LLMs that will succeed will be the ones built by Google, Facebook, and OpenAI, because they have the most data and all. But beyond the foundational models, in the niche market, we will create a lot of different products. Jasper is an example, Copy.ai is an example. I think what Adobe did is an example. They didn't need to build a foundational model. They just created like something really beautiful by focusing on differentiation and cost. So there is a lot that can be done in the niche markets or the products that you're building. But yeah, don't go after building a foundational model or go after like optimizing for costs. I think people are already doing it. The cost thing is like there are open source models that are now getting launched and all that. And which is why Google says that we don't have a moat, because foundational models, somebody is going to open source and give it to the world, just like Google did it with Android. But the computation costs and the focus to build a particular experience will come from a company that is focused on a particular use case, and that is you, right? So that would be all. Thank you for joining. And again, check pmcurve.com. I think we have a growth cohort launching next month. And tell your friends. Yeah, that's. Now let's go to some of the questions. I can already see great session. Thanks for the compliment. ChatGPT for email response integration. We have Ashish. Yeah, Ashish. So folks, if I've missed some question, you can just comment there and it will reappear. So I can take that. Vinay has this question: any use cases for capability products, not user-facing ones? Yeah, Vinay, so think of it like this. Your fundamental search and recommendation will change, because think of an e-commerce platform, right? Like let's go to Amazon. If you go to Amazon and if I go to this whole page is text. There are ratings and reviews which are text, right? Or if you go to, actually, this is a good opportunity for me to do a shameless plugin. The whole thing is text, right? This whole detail page, and all of this text need to be processed and made sense of. All the reviews need to be processed and made sense of. And all of this is in natural language. So your recommendation of catalog will improve significantly if you use large language models. Your search APIs will improve significantly if you use this thing. And same for a lot of other products. So wherever there is natural language helping, be it recommendation, search, your customer success products, your sales products, your marketing products to some extent, everywhere, I think this is going to help. And what more is, with the Codex AI that OpenAI launched, people are now using like this Copilot, right? So Copilot is built on GPT. So coding is going to fundamentally change because of that thing, right? I hope that answers your question. I think the calculation thing is solved. Tokenization is there. Cost is a major limitation. Any reason input and output price difference? Yes, see, input is a question processing, right? So the processing is very, very different than input and output. Output is a cost sort of text generation. Text generation will use a very, very large model, like this 175 billion parameters model. The understanding what the question is will require a very small, very simple model. So which is why the input is cheaper, output is more expensive. I think Arun has already answered, but just wanted to touch upon. Madhav has this question: can companies build moat when they are using OpenAI API to build their core product? Madhav, this is already answered, but feel free to add another question if this is not. So data will become an advantage. You solving for a particular UX, like Adobe has already users who are designers, right? So them building their product better is an advantage. So you either use your scale, or you create a very, very niche custom flow for a particular product use case, or you have some particular data that you have curated or data that you have generated, which you can train people on. For example, if I build something on top of my course, some growth assistant on top of my course, that will be very different because it is built on curated set of data that either I have written or curated set of articles that I've accumulated over the years. So that becomes a competitive advantage. So your data is your moat. But so is your user, so is your scale, so is your network effect and other things, right? Okay, great. Thank you, folks. A lot of thank you notes. There is one Jai Bihar quote. Okay. That makes me laugh. Code interpreter plugin is also available. Yes. So Ankit, I think code is on Codex AI. So just go and read if you're more into Copilot in Codex. I think you should read if you're more interested in that. Neil has this question, interesting question. What are some frameworks or mental models you would suggest while thinking about optimal mix of humans, deterministic software and probabilistic? That's hard to answer. See, I'll give you like three-step guideline, right? So first is think of what problem are you going to solve in your product using LLM? Whether it is a core use case, whether it is a adjacency, or whether it is something built fundamentally on LLMs, right? The second step is look at your other advantages, because see, the moat is still the moats that you had earlier, be it your user base, be it your network effects on your platform, be it a certain kind of paying users on your platform. The moat is still that, right? So think about that particular thing. And then finally, like, see if it makes sense basis the first two, right? So if you are thinking of creating something in design, beating Adobe, it will be very hard. But if you are thinking of creating something for a specific use case for designers, it is still possible, right? Same for PMs. If I'm thinking of creating a product plan or like some roadmap software for PMs using generative AI, other roadmap softwares are not going to sit around and let me do that. So they have that moat already. I have to think of a fundamentally different product if I want to build something using LLMs and win. So the moats don't change with LLMs introduction, but the ones who catch up faster will definitely sort of create some moat of their own, right? So that would be my like 3-pointer on that. How effective are such current open source LLMs? Aman, they're pretty effective, I would say. So there are like people who are still testing it in playground.ai and all. I think people have published, see, like anything, different models have been useful for different things, right? So these smaller models, even if they're smaller models, they would excel in certain things and not excel in other things. The biggest advantage of building a very big model is it will excel at everything. But my point is, do you even need a model which excels at everything? If you just need your customer chatbot to be built, why do you need a model which can talk about what Pluto thought about the Republic and all? You don't need that. So my sense is definitely understand their limitations and use them. One of them will be useful for most of the things that you're thinking about. You don't need to go super expensive on that. That said, look at the computation cost that you'll have to incur. Make sure that is not a hindrance, because see, GPT is not expensive because GPT has access to a tech which nobody else has. GPT is expensive because processing cost is actually high. Yeah, so that is there. Where can I find this meeting recording on YouTube? I think it will go on PMCOF channel. It will also appear on Growth Catalyst. So if you are anywhere like on Growth Catalyst or YouTube channel, you should be fine. I think this is done. How to build and scale products for LLM space. Any use cases for, okay. So another question is crowdsourced news edit. Primarily using sentiment analysis. Yeah, that can be done. Chanchal, I think this is a perfect solution for that. You should explore it. The good thing is it can also do translation very well. And it can also do costly. Yes, it will be costly. It will be costly actually. But yeah, actually that's the problem. Like unless you're monetizing like Adobe and Notion and all, it actually becomes very costly. So definitely pay attention there. Llama, I think, look at Llama. Llama is open source, I feel. And it's also a 6 billion model or so. But again, I'll have to Google but just like ask ChatGPT what are cost effective alternatives to ChatGPT, and it should answer you. Yeah. But look at open source LLM models. If you Google that, you'll get a lot of open source LLM models. Yeah, that would be all, folks. I think I can still see 70 folks here, which is a great thing to see. Thanks for joining, and see you around.